This question is about fuel cells. In a methanol-oxygen fuel cell, the overall reaction is shown below. It has an EMF of plus 1.2 volts. At the positive electrode, oxygen reacts with hydrogen ions to form water. Give a half equation for this reaction. So because this is a half equation, I'm actually going to ignore some of the information because I'm going to use the rules and I'm going to turn oxygen into water using the rules. You'll see that the hydrogen ions come as part of that equation, but I'm going to balance the oxygens by adding water. So I've got 2 waters. I'm going to come back over to this side and balance the hydrogens with hydrogen ions and the charge with electrons. At the negative electrode, methanol reacts with, we know that water is part of our balancing process to produce carbon dioxide, and we know hydrogen ions are part of our balancing process. So I'm going to use the rules again. So methanol is going to become carbon dioxide, the C's balance. I'm going to add an extra water to balance the 2 oxygens in carbon dioxide. There's already 1 in methanol. I can see that there are 4, 5, 6 H's on the left, so I'm going to add 6 H pluses and 6 electrons. The standard electrode potential for the CO2 methanol electrode, which is our negative electrode, our 8.2 answer, is 0.03. So remembering that, the negative would be on the left, so 1.20 volts is the right-hand side, so the positive electrode, so the one we don't know, minus the left-hand side. And so X equals 1.23 volts. It's got to be a bigger number, and when you have them on a number line, so the positive electrode has to be the more positive, the negative electrode has to be the more negative of the two. The difference should give the reading on the voltmeter, so they're 1.2 volts apart. State why a fuel cell does not need to be electrically recharged, and that's because we keep supplying our fuel, our reactants are supplied continuously. So we keep feeding in more methanol and oxygen, and we keep getting out our 1.2 volts. Suggest one advantage of using methanol rather than hydrogen. So this is because hydrogen's a gas, methanol is a liquid, so is easier to store and transport. Methanol is a liquid, hydrogen is a gas. Hydrogen would need to be compressed to be able to be stored and transported.